content of this vlog is all about broken symmetry. But for me, I will talk about what is the definition of symmetry. So guys, alam nyo ba kung ano ang ibig sabihin ng symmetry? We probably heard the term symmetry many times. But do we really know what is symmetry? So symmetry is a concept that is commonly found in math, especially in geometry, but it is also used in arts and design. An object that has symmetry can divide into two identical pieces. So for example, bibigyan kita ng isang piraso at ng papel at hatiin natin ito sa dalawa ng pantay. So isa yan sa mga halimbawa ng symmetry. So sa isang definition naman ng symmetry ay it is a mathematical concept as well as an aesthetic one. Pag sinabi natin aesthetic ay ito ay maganda. So it allows us to classify different types of regular pattern and distinguish between them. In mathematics naman, a meaning of symmetry defines that one shape is exactly like the other shape when it is moved, rotated, or flipped. So there is an existence of symmetry. If there's one object that we can turn upside down, we can change its shape into anyone we want, but it is equally, so there is the presence of symmetry.
Hey guys, it's me, Jeline, and today we're going to talk about symmetry breaking and spontaneous symmetry breaking. So first, let us define what symmetry breaking is. Symmetry breaking is a uniform symmetry of a mixture that is unstable, with the same patterns occurring repeatedly and grows continuously. So how can we simply understand what symmetry breaking is? You think of a pond as a plane. Now think of tossing a pebble in the pond, causing the pond to be disturbed. This is symmetry breaking. The pond has lost its symmetries but not all. This is why we see ripples, or patterns forming. Now let's move on to spontaneous symmetry breaking. Spontaneous doesn't imply that there is no cause at all. In hindsight, there is a cause but it cannot be seen by the naked eye. The best way to explain this is through the BZ reaction, in which, in this experimentation, a mixture in the form of liquid mixed with red and blue dyes are placed in the dish and left for several minutes. And after several minutes, blue dots appear, and within these blue dots are red dots. And this go on continuously. This is spontaneous symmetry breaking. There is no seen causes for the symmetry to break, unlike in the symmetry breaking of a pond, which is caused by the pebble.
Hey guys, it's Zayan, your future RN. And for today's video, I'll be explaining the BZ reaction invariance principles of Einstein. Domains containing spiral waves form on a stationary background in a photosensitive Belousov-Zhabotinsky reaction with light-induced alternating non-local feedback. Complex behavior of colliding and splitting wave fragments is found with feedback radii similar to the spiral wavelength. A linear stability analysis of the uniform stationary states in an oregonator model reveals a spatial symmetry breaking instability. Numerical simulations show behavior in agreement with that found experimentally and also predict a variety of other new patterns. To further explain the BZ reaction, let's watch this video.
I'm going to demonstrate the Belousov-Zhabotinsky reaction. Over here, I have 4 chemicals that we've already mixed up: sodium bromide, sulfuric acid, and malonic acid. And there's a 5th chemical I'm going to add, which is a colouring, which will show us exactly how the reaction is progressing. Mix them all together, and it's sort of brownish colour, and I give it a shake and it turns blue, which is a good sign. And I pour it into the dish here, and then I'll give it another shake, and now it's going brown, which is also a good sign. And now we'll just wait for a second and see if it will do what I want it to do, and in fact it's already started. Of its own accord, little blue dots are appearing, and those dots are spreading and forming blue patches. And as the patches grow, inside them we see little red dots which grow, and inside those are blue dots which grow. And the whole thing just keeps growing and spreading, and this amazing pattern appears like magic from nowhere. But it's not magic, It's symmetry breaking. The uniform symmetry of the stirred up, shaken up dish is unstable. It won't stay that way. Tiny little bubbles, little specks of dust, something start out those blue patches, and once they've started, we just get these beautiful patterns which grow and grow.
Hey guys, it's Arlene, your future RN, and for today's video, I'll be explaining the simple faults in Curie's symmetry principle. So, in Curie's symmetry principle, he stated that when certain effects show a certain asymmetry, this asymmetry must be found in the causes which gave rise to it. In fact, many people have thought that Curie's principle itself is just obviously true. However, in the simple failure of Curie's principle, Brian Roberts describes a way in which Curie's principle fails. Roberts asked us to imagine a different symmetry transformation, one in which instead of swapping left for right, it is the direction of time itself that is reversed. A nice way to picture this is to think about a film. If we imagine filming our pendulum swinging back and forth, the time reversal symmetry transformation will make our example look as if this film is being played backwards. When we play a film backwards, unlike in our parity transformation, everything remains in the same position in each individual frame, and it's only the direction of movement that changes. In our example, the weight of the pendulum keeps swinging back and forth after it's been released. At every point after its release, therefore, the weight has a direction of movement, and so under time reversal, this direction of movement will be reversed. If the weight has a direction of movement and this effects, and this direction of movement is reversed by the time reversal, then these effects are not invariant under this symmetry transformation and so aren't symmetrical. If our initial state was invariant under our symmetry transformation, and all of these subsequent states are not invariant under the symmetry transformation, then it looks as though we've found a way of getting out what hasn't gone in after all. Roberts has shown that in the case of time reversal, Curie's principle fails. Thank you.
For the chapter review of chapter 6, the author did a great job in indicating and writing down theories and researches connected to symmetry and spontaneous symmetry breaking. However, the works were not cited at all on the page, which makes it harder for any reader to locate any of the sources. But however, the chapter was short, concise, a little repetitive, but all in all it was okay and well written.